Okay, so welcome to Mathstoria, and let's have this factoring quadratic expressions having 1 as the leading coefficient. So for this given quadratic expression, this term is the leading term. So the term with the highest exponent and the coefficient of the leading term is called the leading coefficient. So for this given, the leading coefficient is equal to 1. So to factor this quadratic expression, we have these different steps. So first, we need to write two sets of parentheses. So these are the two sets of parentheses. Then the factors of the first term. Since the first term is x squared, so the factors of x squared, that's x times x. Then write all the factors of the third term. Since the third term is negative 10, so we need to list all the factors of negative 10. Since 10 is negative, so one of the factor is negative and one is positive. But since the middle term is positive, so therefore the bigger number must be positive. So for the factors of negative 10, we have 10 times negative 1. So the bigger number must be positive. Then we also have 5 times negative 2. So these are the factors of negative 10. Then the sum of the factors of the third term must be equal to the coefficient of the middle term. So we need to add the factors of the third term. So we have 10 plus negative 1, that's positive 9. Then 5 plus negative 2, that's positive 3. Since the sum of the factors must be equal to the coefficient of the middle term, and the coefficient of the middle term is 3, so therefore, the factors of negative 10, we have positive 5 and negative 2. So these are the factors of this quadratic expression. Then for this given, so write two parentheses. Then the factors of the first term, that's x times x. Then we need to list all the factors of this third term. So factors of positive 24. So since the middle term is positive, so therefore, all factors must be positive. So we have 24 times 1, then 12 times 2, then we also have 6 times 4, and 8 times 3. So these are the factors of positive 24. Then add all the factors. So 24 plus 1, this one is 25. 12 plus 2, this one is 14. 6 plus 4, this one is 10. 8 plus 3, this one is 11. Since the sum of the factors must be equal to the coefficient of the middle term, which is equal to 10, so therefore, the factors of positive 24, we have positive 6 and also positive 4. So these are the factors of this quadratic expression. Then for this given, so write two parentheses. Then the factors of the first term, we have x times x. Then list all the factors of the third term. So negative 18. Since 18 is negative, so one of the factor must be positive and one is negative. But since the middle term is negative, So the bigger number must be negative. So factors of negative 18, we have negative 18 times 1. So the bigger number must be negative. Then we also have negative 9 times 2. Then negative 6 times 3. Then add all the factors. So negative 18 plus 1, this one is negative 17. Negative 9 plus 2, that's negative 7. Negative 6 plus 3, that's negative 3. So the sum of the factors must be equal to the coefficient of the middle term, which is equal to negative 7. So therefore, the factors of negative 18, we have this negative 9 and positive 2. So these are the factors of this quadratic expression. And for this given, so write two parentheses. And the factors of the first term, we have x times x. Then list all the factors of the third term. So we have these factors of positive 45. Since the middle term is negative, so therefore the two factors must be negative. So we have this negative 45 times negative 1 because negative times negative is positive. Then we also have negative 15 times negative 3, negative 9 times negative 5. So these are the factors of positive 45. Then add all the factors. So negative 45 plus negative 1, that's negative 46. Negative 15 plus negative 3, that's negative 18. Negative 9 plus negative 5, that's negative 14. So since the sum of the factors must be equal to the coefficient of the middle term, so therefore the factors of this positive 45 is negative 15 and negative 3. So these are the factors of this quadratic expression.